Hi YouTube, this is Andrew. I'm going to talk today about some of the more abstract, complicated concepts behind Mach's principle and the Mach hypothesis that I developed and how it works. I wanted to first introduce you to the notion of an equivalence class. So the number 2. Um, that is an equivalence class, and there might be another name for this, but when I'm looking for abstract concepts, it's difficult for me to find out how other people worded this. So I'm going to call a pseudostate the ways which you express an equivalence class. So for 2, the number 2, an equivalence class would be 1 plus 1. Not an equivalence class. A pseudostate would be 1 plus 1. So for the equivalence class of 2, a pseudostate would be 1 plus 1. Another pseudostate would be 3 minus 1. That would be for the equivalence class 2. And another one would be 4 divided by 2. That's another pseudostate. So you kind of get the idea of pseudostates. And now I want to introduce you to this picture of these two circles. And I want you to suppose that these two circles are also an equivalence class. And so how would you describe this situation? Most people would say that there are two balls or two circles at rest, and that's one pseudostate. Another pseudostate is that this whole frame and the two circles are in motion. They're going up at 1 meter per second or something. That's another pseudostate. Another pseudostate would be like your frame of reference is locked to a rotation. These two circles are rotating around. That's another pseudostate. Another pseudostate would be that these two circles are expanding at the exact same rate the distance between them is expanding. So all of these ways, all these pseudostates are ways of expressing this. And now I want you to think of our universe. And pseudostates are a really important concept. When you have an issue with undefined, there's a lot undefined in this reference frame. There are many ways we can express them. But I want you to suppose that of all the pseudostates that you can think of, the only ones that are relevant are in terms of mass. So one mass in terms of another. Any other pseudostate that you come up with is irrelevant. It has no consequence. And so I want you to take the perspective of assume we're in our universe, and we take the example that I mentioned in my video, The Democracy of Matter, of two masses which are rotating around. And one is rotating in one direction and the other is rotating in the opposite direction. And so there's a background star. And I want you to suppose that relative to one frame of reference, according to the symmetry of angular momentum, that the tangential velocity, this is a pseudostate, of the background star, is 1 meter per second, and we'll put it in an arbitrary coordinate system, and we'll say it's going 1 meter per second in the east direction. And then we have a planet next to it, so we'll call this planet Venus, and it's spinning in the opposite direction, and this background star's tangential vector is 1 meter per second in the opposite direction. Now, a physicist would look at this and say, well, I need to ascertain the background's true rotation. And the notion of doing that is fallacious because the background frame doesn't have a background frame by which to gauge this motion. So the way you go about tackling this is you forget about the background's true rotation. It's undefined. You'll never be able to figure it out. But what ends up happening is Okay, so say we take it from the perspective of Earth, and the rotation's going around, and it yields a tangential vector of 1 meter per second. And after a time of t, let's say, what's going to notice is that the the angle or the delta theta of the stars have displaced, let's say, 1 degree. And as a result of the vector being tangential, there is an r vector, that an r displacement, which is greater after time t. And so, from the perspective of Earth, we if the universe were rotating around us, we wouldn't even say it was rotating around us. What we would say is that that the Earth is rotating. So that's what I kind of want to get through your head. But what ends up happening is the resultant vector of the tangential velocity. We're left with that, and that is the centripetal acceleration. It's the negative of the centripetal acceleration, so it's an outward centripetal acceleration. And so, say you have the planet Venus, and it's going in the opposite direction, and you ascertain the tangential velocity in the opposite direction. You don't negate those tangential velocities. What ends up happening is it's both of those frames of reference are valid, and the centripetal acceleration is added. It's like a resultant centripetal acceleration of the two perspectives, and that's the way it works. It's as simply as I can describe it to you. It's actually a very, very complicated idea, but that is as best as I can describe it, at least right now. I'm really trying to make this simpler for you to understand. But that is why it's not as though the foreground imparts a centrifugal force on the background. It's a little bit different. It's a negative centripetal acceleration. So that's what I want to kind of impart upon you. And that is what I think is the driving force behind the expansion of the universe. Thank you very much for watching. Have a good one. Bye.